Math holds a unique position in the modern school curriculum. It is the only subject required of almost every student on Earth, and the one most consistently dreaded by those forced to study it. Governments pour billions into curriculum reforms to raise test scores, yet employers continually warn of a massive shortage in quantitative talent, while students stare at textbooks and ask, "When am I ever going to use this?" To figure out why this system is failing, we can apply the very same logical process that drives real-world mathematics, a framework called computational thinking. And the first step of that process is to explicitly define the problem. There is a total divergence in practice. The mathematics taught in classrooms and the mathematics used to solve problems in the real world operate in different realities. Globally, secondary school students spend roughly 3 hours a week practicing manual calculations. Add that up across the world, and we are expending about 240 average human lifetimes every single day training humans to perform algorithms that a machine can execute in a fraction of a millisecond. This enormous expenditure of human capital happens because every mainstream math curriculum is built on a single silent premise. It assumes computers do not exist. The existing curriculum has successfully optimized for a set of skills that the real world abandoned decades ago. Moving to the second step of our logical framework, abstraction, we have to strip away the noise of rote memorization and manual arithmetic to find what mathematics actually is. This flowchart maps the true essence of mathematics, a 4-step loop to handle complexity: define, abstract, compute, and interpret. For centuries, that third step, computation, was an incredibly expensive bottleneck, restricting how humans could iterate through the loop. Because humans were the only available machinery capable of performing that computation, early education had to dedicate almost all of its resources to the pure mechanics of hand calculating. It is exactly like forcing a modern photography student to spend all their time learning how to coat glass plates in light-sensitive chemicals. Ultimately, it was a mechanical requirement of a specific era, not the actual art of taking a picture. Our schools became trapped in that past era. They mistook the mechanical production line of executing calculations for the actual purpose of problem solving. If we move to step 3, compute, and look at the historical timeline, the arrival of digital machines changed how we handle logical operations. Computers automated the computation step, executing complex operations instantly and removing the historical bottleneck entirely. Professionals in the real world offloaded the burden of calculation to these machines. This shift directly enabled humanity to model flight trajectories and put an astronaut on the moon. Yet facing the exact same technological reality, the classroom environment stubbornly ignored the new machinery. It continued to train humans in manual arithmetic, treating calculation as an end in itself. While the physical machinery of the modern world changed, the education system failed to update its operating system, producing graduates whose primary skill set is easily replicated by a pocket calculator. Now we arrive at the final step of our loop, interpret. We must assess the data and look at the consequences of maintaining our current educational trajectory. By forcing students to focus almost entirely on manual calculation, we are training them to compete directly with modern computers and artificial intelligence. This is a competition humanity is mathematically guaranteed to lose. To thrive in the AI age, the curriculum must move away from calculation and toward a broader discipline, computational thinking. This diagram shows the required division of labor. Machines must entirely take over step 3, acting as our engines for computation. Humans must focus exclusively on the remaining steps, defining messy problems, stripping out noise through abstraction, and interpreting data to make better decisions. Instead of memorizing the rote math behind predictive models, a student's role should be managing the machinery to solve actual crises, like predicting climate shifts or analyzing trade policies. Relieved of the need to function as manual processors, students gain the logical experience to navigate the complexities of the AI age. This return to first principles ensures that the subject provides a practical advantage in everyday life.